Now in your session we continue with the previous one. In the previous class we know different medium and the sound propagation in different medium. Now in case of solid, the propagation of the sound, that means the speed of sound, is maximum. Now every medium has its own elastic behavior. That elastic behavior is called the bulk modulus of that material. Now as the solid are a composition of the large number of particles and they are congested to each other, that's why the vibration of the particles is much greater in the solid. In that case, the solid medium, in case of sound propagation in the solid medium, is maximum. That means the velocity of sound in solid medium is maximum. Now in case of liquid, as the liquid corresponds to a less number of particles density compared to the sound, that means the sound propagation is liquid is much less compared to the solid medium. In case of gaseous medium, the particle density is maximum less amount of compared to solid and liquid in case of gas. So the particle density is very less in compared to the gas. That means the sound propagation or the speed of sound is less in gases. So V solid is greater than V liquid is greater than V gas. So velocity of sound in solid is greater than the velocity of liquid, and the velocity of sound in liquid is greater than the velocity of gas. Now there are different factors which affect the speed of sound in case of gaseous medium. There are two important principles which actually states the velocity of sound depends how. Now first, scientist Newton said that whenever sound propagates in a gaseous medium, then this process should be an isothermal one. What is isothermal process? If the sound propagation generated in such a manner that there is no change in temperature, then this kind of property is called the isothermal change. In this case, the velocity of the sound is equal to root under P by rho, where P is the pressure created by the sound for the propagation in case of air or gas, and rho is the density of that gaseous medium. So this calculation holds good but cannot be valid because this equation cannot calculate the speed of sound in gas accurately. So scientist Laplace formulated another principle which states that the velocity of sound in a gaseous medium is an adiabatic process. What is adiabatic process? Adiabatic process means if sound propagates in a particular kind of medium, inside the medium temperature can be changed, but there is no change in temperature between the systems and that gaseous medium. So this kind of change is called the adiabatic change. So sound propagation inside a gas is an adiabatic change, or in this case this is equal to gamma P by rho, where gamma is called the molar specific heat constant, P is the pressure, and rho is the density. Now from that above calculation, the velocity, standard value of the velocity of sound in gaseous medium is nearly equal to 332 meter per second. It can be varied from book to book from 332 to 340 meter per second. So this range can be possible because those are the approximated value but close to accurate one. So those are the properties which can actually affect the velocity of sound in gaseous medium. One is pressure. If you increase the pressure and the density simultaneously, then the velocity of the sound also increase. The pressure does not affect the velocity of sound independently, but the ratio of pressure and the density can affect the velocity of sound. Moreover, the temperature can be varied. If the temperature can be varied and temperature is increasing, gradually increasing, the velocity of the sound also increases. Likewise, if the humidity of the air or the gaseous medium is increased, then the velocity of the sound also increases. But if there is no medium for the propagation of sound, mind it, in this case sound cannot be propagated. That's why the collision in the universe cannot be heard by the us, and it is the speed of sound is very less compared to the speed of light. Like the speed of light in air or gaseous medium is found to be 3 into 10 to the power 8 meter per second. So this is the velocity of light. But in case of velocity of sound, this should be 332 meter per second. Those numbers is very much amusing. This is very high, this is very low. That's why we can hear the sound of a thunder much less much after than we hear the light, we see the lightning. So lightning is seen faster than the thunder is heard. So this is the case, as the velocity of sound is very less compared to the velocity of light. That's why lightning is seen first. Now we know the definition of frequency. So frequency actually affect the sound. Now frequency, if the number of frequencies increase, the pitch of the sound is also increased, but the frequency cannot be heard if the frequency is less than 20 Hz and greater than 20 kilohertz. That means if the number of vibration is less than 20 times per second, or the number of vibration is greater than 20,000 times greater, then these sounds cannot be heard by us. So the range of frequency is 20 Hz to 20 kilohertz is audible to us. So 20 Hz to 20 kilohertz is the frequency range in which sound can be heard by the human beings. If it is less than 20 kilohertz, if it is greater than 20 kilohertz, then this sound is called ultrasound or ultrasonic sound. If it is less than 20 kilohertz, 20 hertz, if it is less than 20 hertz, then it is called infrasonic sound. So those are the different sound systems or sound phenomena which we can differentiate with respect to the frequency. If the frequency range is 20 Hz to 20 kilohertz, then it is the audible sound which is audible for human beings. If it is greater than 20 kilohertz, then it is called ultrasound, and if it is less than 20 Hz, then it is called infrasonic sound. Now if the object speed is greater than the speed of sound, then the speed of the object is called the supersonic speed. Normally jet plane are in the range of supersonic speed because the speed is much greater than the 332 meter per second. That means the speed compared to the speed of sound, the objects are very much faster. That's why those speeds are called supersonic sound. Now there is important phenomenon of the ultrasonic sound. Some animals like dolphin or dogs can or bat can emit and actually transmit or the ultrasonic sound. Due to that effect, ultrasound can be used in medical sciences like cancer cell determination or ultrasonography, and in the case of deep mining in the measuring the depth of the ocean, we can use the sonar, sound navigation and ranging technique by using the ultrasonic sound. So there are the use of the ultrasonic sound, but the common properties of sound are like sounds are the sound waves are the longitudinal wave which propagates through a medium or requires a medium for the propagation, and it has an audible range which is 20 Hz to 20 kilohertz. Now the echo. What is echo? There are a reflector which actually reflect the sound. This is the source of the sound in which the sound propagates, and after propagation it will hit a particular reflector. Then what happens? In the previous class we know about that term.